Um, my name is Eva Simonsen. I'm a senior human and organizational factor specialist at Vattenfall. I've been working in the nuclear business for over 15 years now. And recently and currently, I'm working with transitioning one of Vattenfall's nuclear power plants. We are closing 2 units and keeping 2 units. So we had to transition the organization from a 4 unit plant to a 2 unit plant, which of course includes a lot of organizational and human factors issues and competence questions to handle. But I haven't done this work on my own. I have worked together with two colleagues, Anders Ivarsson, who is also a senior human and organizational factors specialist, who is currently working with these issues related to the decommissioning of two of Vattenfall's nuclear power plant, which of course also you need to look into the competence and staffing issues there as well. And then we have Claes Andersson, who is a senior licensing specialist, who has over 25 years experience from working in the Swedish nuclear industry but also in the United Arab Emirates with building new nuclear there as well. And some assumptions. There are many decisions that are not yet finally made. So to be able to make our analysis, we had to make some assumptions to base the analysis on. And one was that the reference technology for the study was to look at the staffing if the GE Hitachi BBRX 300 were to be used, and to look into the staffing and competence needs for 1 unit, but also to see how a possible addition of another unit at the same site would affect staffing and competence planning. And one thing to note with the reference technology, another kind of also assumption connected to that is that this technology will have been, the primary licensing will have been done abroad, for example, in the States and in Canada, so that the licensing process in Estonia, the local regulator can focus on the kind of specific licensing for the site and any detailing for that, so to speak. Yes. And some limitations. This study, this analysis covered the startup, the competence needed to start up and implement a nuclear program up until and including the point where we have reached safe and stable operation, meaning that the rest of the nuclear power plant life cycle has not been covered in the work this far. Also, we have not looked at the staff of subcontractors and actors further down the supply chain. And of course, this development strategy is something that needs to be iterated further as the process goes on. When the road becomes clearer, then these kind of staffing needs to be planned in more detailed and iteratively finalized, so to speak. And for the method, Henrik talked a bit about this in the introduction, but we had some IAEA guidelines so we used as input for this work, but also a staffing proposal from the vendor of the reference technology as well as a previous analysis made by Finnish VTT in 2019 was also valuable input for us. Of course, also our own experience from working in the Swedish nuclear industry and also in Class case abroad. Henrik talked about the EA milestones approach, the phases he showed you, the concept of creating a conceptual statement, and then the HOA development strategy and the workforce and training plan and so on. But also specifically, EA proposes a workforce planning process, which is basically the figure you see here on the right, which is about you have to identify your needs, identify any gaps you have. Okay, these are the needs, what is available in the specific country where you want to build, and how do we address these gaps and develop the workforce plan based on that. And some results. These are the competence areas that we identified. And if you're a very quick reader and very observant, you will note that these areas are very different in size. Some are very broad and some are very narrow. some of the very narrow ones, for example, safeguards, we wanted to include because they are very important to nuclear. They are very special importance here, and we wanted to add them to make sure that they are included and not forgotten. And for the broader ones, for example, mechanical engineering, they will be broken down more in the next step. So as I said, this is an iterative work, but these were the competence areas that we based the analysis in the first step on. And one thing to note here is that it does not say nuclear or radioactive or radiation in front of every single line here. As Henry said in the beginning, there are many conventional competence areas here, such as IT and mechanical engineering and chemistry and so on. We also, when we had the competence areas and identified the gap between what is available in Estonia, we defined high-level sourcing strategies, which are A to D, that you see here on the left-hand side. A is where the required number FTE, that is, FTE is full-time equivalent, if you're not familiar with that acronym, that the required number of FTEs in the competence area are currently and will continue to be available in Estonia. So there's no need for a long-term strategy, sourcing strategy here. Then there are some competence areas where there are people with the relevant base training education available in Estonia, but they will need a shorter, under a year, more nuclear-specific training or education to fulfill the competence requirements. This is the B category. And then we have C and D, where we see that there is a gap, or a larger gap, perhaps I should say, that needs to be filled. Where C is competence areas where you need a longer nuclear-specific training or education. For example, the operational personnel of nuclear power plant will need that. Or as Henry was talking about, the mere nuclear engineering or nuclear physics specific training, for example. But also some competences are better learning than not learning by doing rather than sitting in a classroom, for example. You have to learn on the job. And the sourcing of experienced personnel, or I should say creating experienced personnel, as Henry said, is another sourcing strategy. Either you can maybe source one or two foreign experts, and then they can train Estonian personnel on the job. But that needs to be planned for, since it will take time to get there. And also the pyramid that Henry showed in the beginning shows the kind of level of nuclear specific knowledge needed. And these are not exactly the same as the sourcing strategies, but there is a connection, as I've tried to indicate on this slide, where the A and B mostly correspond to the nuclear aware category. This is where the bulk lies. Most of C and D will be in the nuclearized category, and some of C and D will be in the nuclear category. So it's at least it's somewhat pyramid shaped, as you can see. The bulk is in the nuclear aware category here. And we started on the workforce plan. I'm trying to switch slides here, sorry. My clicker don't work. So, no, okay, it was just delayed, sorry. Here. For each competence area, we have estimated the number of FTEs per phase. And you see here the blue ones are for owner, the orange and yellow one is for the regulator, that actor, and the gray ones, very small, so maybe a bit hard to see, is for the government. But as you can see, different actors will ramp up in different phases. Of course, because there need to be a regulatory framework developed before you can license towards that regulatory framework. So you need a regulator earlier, and you need the government to initiate the regulator before that can happen. So they are more front-loaded, whereas the owner staffing will ramp up more in phase 3. And also for the reference technology, we see that the owner staffing will be lower for an SMR than it is for a traditional plant, because there is a more shared services, for example, to take advantage of, and a larger degree of standardization. And we also have anticipated, as you all might recognize the feeling that it's difficult doing something the first time in this city when you kind of learn something. And to balance this initial period of operation, we have increased the staffing here to kind of get things running and get all the work routines and so on working properly in the beginning. So that's also kind of included in the FTE estimate here. And that is the extent of it. We have estimated the what are the competence areas that are needed and the gaps and so on. What are the number of FTEs needed here? And again, what can be noted is that the need for highly specialized nuclear knowledge is limited, and that we can utilize the existing experience in Estonia to a high degree. And that's all. Thank you.
Thank you, Eva. We now have a couple of questions, some for you and some for Henri. So perhaps first for you. Was there an environmental specialist on this long list, what you showed? If not, then why?
It's kind of divided in different competence areas now. It can be viewed as part of the licensing reference category, for example, or some environmental issues regards to chemistry and so on. So I suspect this is something that will fall out more clearly in the next step when we detail the broader areas more.
Okay, that's great. And another one for you. We saw from your presentation that the regulator had approximately 30 people. Why is that? Isn't that too low?
Well, as we said, the estimate here for the reference technology is that primary licensing for the reactor type has been previously done, so the focus can be on the specific site and therefore lower.
Okay, great. Thank you very much. And Henri, has Fermi offered any internship programs to work in nuclear power?
If you're saying something, I can't hear you.
No, I'm asking a question from Henri now, if you can hear me.
Now I hear you.
Okay, great. So Henri, once again, has Fermi offered any internship programs to work in nuclear power plants for Estonians?
Yes, that's a good question. So currently not yet, but actually we are already working with that because this is very important for us to assure that we have a competent workforce. For example, you saw Robin Manley today earlier from Canadian first BVR X300 development program. So we have discussions with them that if their program will go forward, then at some point it would be possible to send Estonian people to work in that project. So.
Okay, I agree that it's definitely very important. And perhaps another question. Would it be possible for current oil shale industry workers to get employed in a nuclear power plant in Estonia?
Why not? As I told before, there's a lot of very conventional expertise needed. There is electricians, automation, there is INC, there is mechanical engineering. There's a lot of things. But of course, the people, they need to have certain English knowledge. Certain knowledge is needed, but I see no problem. And of course, the age, maybe if you think that if we start operating in 10, 15 years, then the people should not be retiring in the following 2-3 years, you know. So people under 50 currently, definitely they have a chance.
Okay, great. Thank you both for your presentations and answers.
Thank you.